In the previous video, we actually talked about a lot of stuff in this, alright, but it's unrelated, but it's good to know anyway. So now we talk about the topography of your surface. Topography tells you about the different profile or surface profile of the thing. Alright, if you were to go to search for topography, yeah, you can also be applied in the map, alright, a detailed map of the surface or whatever. Okay, at least you get to know the meaning of that. So we uses this type of concept in also the surface of your material. So we are talking about that. Alright. And therefore the surface is irregular and rough, hollows. So the hollow is actually this thing. Alright, the one that is going in depth. While the peaks are the one that is coming up. Or the peaks. So these are the peaks. Or you can say that these are the peaks. These are the hollow. Okay, these are the hollows also. Alright. And two real surfaces that are contact of each other are called the asperities. Alright, the asperities is all this point. Or they call this the asperities. Or the peaks. Or the peaks, or somewhat they are called it they call it the asperities. Alright, hopefully you are clear. And they use different techniques to actually measure the surface roughness. So they use microscope, different type of microscope, scanning electron microscope, atomic force microscope, optical microscope, or 2D or 3D profile meter. Alright, Taylor Swift, Tally Surf. Tally Surf. Alright, and later on we'll talk about this thing. And the comprises of a vertical needle stylus to trace the profile. Alright, so I believe if you remember in the previous video, and in case I don't think if you never watch, this is your surface. Alright, and then I may have this particular stylus, or I call this a transducer. Alright, and then I'll move, maybe I should use this one. I'll move this thing along the surface. Alright, and then I'll try to test out the thing. So when I test out the movement, alright, I go along the surface, I'll know the surface roughness. So along the way, I'll plot out the graph. Alright, there will be a certain graph that is plotting out. Maybe this is the height, and then this is the thing, and then I'll plot out whether how is it going on. Then I'll calculate certain stuff in order to know my roughness surface. Alright, so our surface roughness. Yeah, so this is what it's trying to talk about it. Alright, and give a statistical measurement of your surface roughness as the graph that I've drawn just now. Okay, so why do we have all this surface roughness? Alright, is because everything exists with a surface roughness. For example, a paper may seem very smooth to you, alright, you touch very smooth. But if you were to go microscopic, alright, there will still be certain rough surface that is occurring at that particular surface. So these are all the things that we are looking at it. Alright, and these are the things that we will these are the little points, or this asperities part are little points that will cause friction. Alright, will cause wear and tear. Alright, and therefore we are looking at it. If you remember the very first part of our tribology introduction, alright, we are looking in terms of friction, wear and lubrication. Alright, so therefore everything is about friction and wear. So we need to first understand the topography of a surface first, and this is why they use the different probes. Alright, so in this over here we use a profile meter. Okay, so it's still using the stylus and the stylus concept. Okay, and if you were to click this link over here, or this image metrology, you would download a certain program, but the program allows you to only use for 2 days, and I don't know how to use it. And you can't create a new file, you can't create it, you need to download their image, or you need to download their file in order to edit from there. So generally I don't know how to use, but it is good if you want to in the future, if you go to industry or whatever, 3D roughness analysis, if they want you to do this, then I will recommend this video, this image, this software. Yeah, but coming back to here, let's talk about this thing. Alright, and eventually let's talk about that later on. Okay, so over here, if I have this particular stylus, I think let's take the picture. So you see, I take my stylus, I move. Alright, as I move, as you can see, my graph is plotting. Right, if I zoom in, you see, as my stylus move, I am plotting a graph. Okay, I'm plotting a graph. You see, so this is the graph that we are just now talking about. Okay, So as I move, alright, it's moving along this thing, and then it plots out the graph. And over here it goes in. But you take a look, there is a answer problem, because you can't measure at this point. This point is unmeasurable. So your program may look that this is actually over here only, that's all. But in fact there is a more deeper hollows, right? Hollow. Alright, and therefore this is the thing. So when you choose a stylus, you have to choose a good stylus, alright, that is able to measure quite deep, or choose an appropriate stylus in terms of different things. Okay, and take note of the stylus radius. Alright, the stylus radius will determine how effective it is to measure the surface roughness. These are the graphs that you're talking about. Alright, and these are the path, you see. So I mean this whole, I should go thicker. So this whole thing are your stylus path. Alright, because you are going in this direction, right? You're going, measurement direction is this direction. Alright, so this whole thing is the path that you take. Alright, 你人生道路. Okay, and therefore there will be a center datum line. Alright, so the center datum line, center datum line is over here. Okay, and it's just a datum line that you reference with lah. So this datum line will give you, or you can say that this is the origin. Okay, so from here this is 0, so maybe this is 1, so you know that this is maybe 1 micrometer, something like that. You get what I mean? So this is how the graph shows you. This is a very so-called small portion of understanding how the thing works, because there is more to this, how everything is talking about. Alright, but I just want to show you a certain stuff. Alright, the definitions of it. So for example, this is your surface. Okay, your surface. They took a portion of it, maybe this portion. Okay, so this portion is called the waviness width. Alright, so you take a portion of it, and then you kind of observe this portion, and this is the point where it's kind of waviness, right? So this is one waviness width, this is another waviness width. Alright, nonetheless this is also another waviness width. So it's more on how you look at the things. Alright, and the roughness width are the width between each of the section. Alright, because maybe if you were to zoom in more into here, you can see that there is certain stuff going on. Alright, so each of these are something like that. So they actually break it down into different paths. Alright, so therefore the difference between this thing and this thing is the roughness width. Okay, I don't know whether am I saying the right thing, but at least you get to think about it lah. Then the roughness height is in between them. Alright, this is the roughness height. Okay, so it's between the peak of this point to this peak. Alright, so this is the roughness height, and the waviness height is total height. Alright, because this is, if you have to go all the way back to this picture, alright, so this is the waviness width, this is the waviness height. Okay, so that's all it is. If you want to make it sounds more so-called analogous to you, alright, this is like a sine wave. Alright, your sine wave, this is your wavelength. Alright, and this is your amplitude, and okay already lah. And then maybe this part over here is the portion that you want to observe or whatever lah, I don't know lah, but at least you try to make connections between them. So coming back here, if I were to take this picture, give me a while. I think this is the side view. Alright, this is definitely the side view. Alright, but the definitions, alright, the height minus the width. Alright, as I say, let's say this is the wavelength. I will believe this is the wavelength. Alright, the what's it called? The waviness width. Alright, so this is the waviness width. Alright, so the waviness height minus the waviness width will give you certain answer. Alright, I think it's the radius, RA max. I don't know, center in line max. So they take H minus W. Alright, it is equals to RA max, and this is how they find their centerline average. Alright, so yeah, how I know why, I don't know how the equation works lah, but really seriously, But anyway, take note that this is not waviness, this is waviness. Alright, it's a waviness with, alright, this thing, waviness with. Alright, so the calculations are all this. Alright, if you think about it, numbers, you actually sub it in. Alright, but I don't know the meaning behind that, most probably because I was playing games during the lesson. So this H over here minus W will give you RA max. Alright, and I don't know how you got that. Maybe I think it's divide by 2. No, it's 1.5625. So it's not 1.575. So something is wrong somewhere, definitely. But take note of everything, and also take note that there is a length of measurement surface. So this is the length of the measurement surface, and I think this is the perpendicular whatever thing. Alright, but at least you get to know the topography stuff in a more detailed way. Alright, and the table surface roughness as a result of common production process. So there will be a table of the roughness surface. Alright, so these are the roughness center. Alright, so I think the center line, if in fact I would believe, is each of this maybe I should draw like that, right? So each of the curve, this is the so-called the roughness RA. This is another RA, I think. Okay, so it's the average peak, right? Peak to peak. Or if you were to come out over here, right, these are the equation that you use, alright, to somewhat get the average peak. So this is the RA. I think this is the RA. Oh, okay, I think this is the RA. Yeah, chim. But he's pointing downwards today. Yeah, he's pointing downwards saying that it's RA. Yeah. After thinking about it, I think what is RA already. Okay, so imagine I have this thing coming in and out, you know, maybe like that. Okay, the RA is a line telling us the average so-called surface that has the most material. For example, over here. Alright, definitely this place is everything is about the material, right? So maybe I should draw a better one. Okay, so let's say this is the material, alright, and this is the surface of the material. Okay, so the center line, alright, is the RA is, it can be here all along. These are all the materials, alright, because these are all the materials. But up to here, this is the starting to get a little bit so-called, there's a gap. You see there's a gap over here. Alright, there is a gap. Alright, so this line, RA line, alright, is trying to determine the top of the surface. Alright, it's trying to determine the surface. Alright, yeah, it's trying to determine the surface, trying to determine the average surface. Alright, because there is so many ups and downs. Alright, so it's trying to give you the average surface of the material. Alright, and therefore this is how they calculated it. Alright, your RA max, center line average. So after thinking about it, yeah, this makes more sense. Yeah, so this is a center line average. Alright, where the materials, if you think about it, why center line average? Because imagine we have a sine wave. The center line average is actually this line, right? Because this portion will cancel out this portion will cancel out this portion will cancel out this portion. End up, right, you'll still get back this origin line. So it's trying to talk about using the sinusoidal electrical wave type of explanation to do that. Alright, but at least you get to know that this is how you determine the surface of your material. Alright, what thickness. Alright, because this is your surface ma. So from this surface to this surface, then you will know that, okay, this is the total thickness of my material. Alright, so if you were to have a different so-called datum line, if it maybe is in blue, alright, then you have a different surface, you have a different thickness already, but it's not very so-called precise, because these are all in terms of micrometer or nanometer. So therefore, definitely you will want to talk about that. But if you have something that is nano manufacturing, then this thing comes into play. Alright, nano manufacturing or micro manufacturing, you're talking about trying to manufacturing what else they call printed circuit board, because they're all very small. You're gonna talk about the tracing lines, everything. So yeah, these are all the things that you're gonna talk about. So therefore, these are all talking about precision manufacturing. But nonetheless, it's a good exposure to things. I know I might talk a little bit about rubbish here and there, but it's kind of helpful, I think, for myself. So next video I'll talk about a bit about this equations. At least you get to know how they came about. But I don't think it's important, but you should get to know how they are being used. Alright, so see you there.